Hello, let's do the New York Times Hard Sudoku for January 11th, 2025. I know all my videos are super late today. Had stuff to do in the morning, so I'm just now getting to record some of them. I don't know that I'll be able to get through all of them before I have another thing to do this afternoon, but I'm going to try to at least get all the videos out sometime today or this evening. Anyway, this is the first one, so yeah, there is, as always, a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I do have two threes here, and this three looks up, putting a three in one of these two. I also, while looking down, I noticed we have two ones and two twos, so I'm thinking that might affect this box in interesting ways. So let's just mark that now. Yeah, for example, the two gets placed. Now these two twos, put a two in one of these two. All right, two and three. We have the 6 and the 9. So the 6 looks into here, putting a 6 in one of these two cells, which it does point down with this 6. Putting a 6 down here somewhere. Some interesting restrictions today. In fact, I'm wondering about 4 and 8. It's really interesting. This cell is not a lot of digits, right? Because we have the 1 and 3 quarter marked. And if we were to quarter mark the 4 and 8, they'd be quarter marked here. So like these aren't 4, 8 in general, and this also isn't 1, 3. So even if we count, we've got 2, 6, 9 given. We've got the 1, 3 corner marked, and then we've got the 4, 8 in the row. So that's already 7 digits that this one isn't. We just need one more digit for it to not be, and it'll be a naked single. I don't know that it is, though. But let's take a look. It's not 1, it's not 2, it's not 3, it's not 4. It could be 5, it's not 6. It could be 7, and it's not 8, 9. So it is those 2 digits that we expected. Knowing the count that you expect can be really useful in reducing human error. When you approach something from multiple directions, and then they meet and agree, that's much better than doing something quickly and then having nothing to double check your efforts and then maybe making a mistake, which can cost you the whole puzzle, make you start over. All right. Anyway, so that was that. These also aren't 4, 8. This one's also not 1, so yeah, this can't be. Let's just think about this whole row, right? Because it can't be the 2, 6, 9 or the 4, 8. So they could be 1, which can go here. They can't be 2. We know they can be 3. They can't be 4. We know they can be 5, but not this one. Right? Okay, that's helpful. They can't be 6. They can be 7, but not this one. And then 8 and 9 are gone. So actually, all of them are worth marking up, but none of them are singles. Okay. Since I marked this 5, 7, I am going to skip ahead a little bit and look at this column, which is down to 4 digits. So I'm wondering if there's additional restrictions. For example, I'm seeing this cell can't be 5, 7. So I'm very interested in what's going on here. What do we need? We need a 4, 5, 6. No, not 6. 4, 5, 7, 8. So we know that this is 4, 8. This is 5. This isn't 4 or 5. So this is 7, 8. And this isn't 7 or 8. So this is 4, 5. Interesting. So they're all different. So we have this quad doesn't resolve itself. There's 2 of each digit. There's 2 4s. There's 2 5s. There's 2 7s, and there's 2 8s, which is annoyingly not resolvable. But anything sneezing on this will resolve the whole column. A little gust of wind will do it. All right. Anyway, we had just done this 2. Yeah, we did the 2 and the 3. So let's just take a look at the 6 and the 9 again. So yeah, I did this 6. It did pointing. This 6 isn't quite good enough. It's limited up here. Okay, and then let's just go through each of these digits. So, oh, sorry, I forgot to do vertically for this 3, so let's just take care of that. I remembered that I like to do verticals now when I look at each digit. And I didn't do vertical for these 9s. Okay, so now back to here. We've got the 1. We have it marked here. There's nothing around here to do. We have the 3, the 4. I keep looking and it seems like there should be something, but it's not quite there, is it? All right, and we got the 7 and the 8. So the 7, we do have another 7 helping, good. So there's a 7, one of those two. And 7's in here somewhere. And then the 8. We get that, that's it. Okay. So I think that's all we get out of this band. We got interesting stuff over here and some good markings here. These pointing 6s are good to remember. Yeah, otherwise I don't think we can complete more. Let's move on to this next band. So we do have 2 6s here, and actually this can't be 6. We can place the 6, which also places the 9. Nice. Following up on this 6, we can place it here. It's in 2 places here. It's in 2 places here, which points, telling us it can't be here. So that's our 6. How are we doing on 6s? We have 1, 2, 3, 4, 5, 6 6s, so they are limited like this. That's what we get. Okay, that's not going to resolve on its own. So we got the 6. We also got this 9. Vertically, we have all the 9s. Horizontally, I don't think we can do anything. And then, okay, let's not do this box yet. Let's just keep looking at buddies for a second here. So we have this 4, which ends up putting a 4 on one of these two. Okay, we did the 6. 7, can't do much with. Okay. Oh, yeah, we marked it vertically. Okay. This 1, we marked vertically. All right, the 2. Yeah, 2's in one of these two. Interesting. Okay, we got it. It's done vertically. We took care of 6 already. Oh, what about 5 though? There's not really much going on with 5s. All right, and then we took care of the 9. Okay. Is there anything else? Yeah, we want to look at this box. So we have 1, 2. We need 3, 4, 7, 8. This can't be 4, so this is 3, 7, 8. I think this could be any of 3, 4, 7, 8. In fact, that's what the column is. The column is 3, 4, 7, 8. This can't be 3, so this is 4, 7, 8. Okay, unfortunately, I don't see anything to do with that. Okay, this box is down to 3 digits. Let's take a look at that real quick. We need 4, 5, and 8. So the 8 can only go here, and then this is 4, 5, making a 4, 5 pair. All right, and that segues us into this bottom band pretty nicely. So we have this 6, 2 6s, we have that marked. We also have 2 3s here. Puts a 3 in one of these two. We also have, let's see, the 7s. This 7 helps, putting a 7 in one of these two. And we have the 8s. All right, 8 one of those two. So the 7, okay, yeah, I don't see anything special geometrically there. Okay, we're going to go through each of these digits then. So we've got the 1. Not much there. The 2. We have the 3s. We did. The 4, 5 pair does affect the rows. So these aren't 4, 5. In fact, this is 3 digits left then. We know the 3 goes here. We have the 4, 5. Oh, we need a 1, which goes here. One of these two. So 1, 3, and the last digit's a 9. Which can go anywhere, unfortunately. Okay, not seeing anything immediate with those. Yeah, that 4, 5 pair, otherwise not doing much. Okay. So that's it for our initial scan. Did I miss anything vertically? I'm not sure that I did. All right, so what are we on the lookout for? I'm going to go box by box, make sure I didn't miss anything. Sometimes I will have marked pointing or claiming and then not respected it when I pencil mark. That's one thing I look for. I also look for cells that may be particularly restricted. So, for example, this cell here is not the 1 or 3, so I'm going to just take a look because it's already not 5 digits, right? It's not the 1, 3, it's not the 2, 6, 9. It's also not the 7 here, so let's just take a look. So it's not 1, 2, 3. It could be 4, 5. It's not 6, 7, 8, or 9. So yeah, it's down to just 4, 5. That does make a 4, 5 pair in the column. So basically, another thing we could have seen is that because this cell's not 1 or 3, and this is filled with non-1 3s, and then this cell's not 1 or 3, it does put a hidden 1, 3 pair here. But either way, this is reduced to 1, 3, however you want to do it. And then the 3 actually can't go there. So that's 1, that's 3, that's 7, that's 5, and that's 4, and that's 8. Resolves the 4, 5, and the 4. Resolves the 3 there, and the 4, and the 8, and the 7. Wow. Something sneezed on it, and resolved the entire stack. Okay. This 7 looking... Oh, sorry, I thought we didn't have a 7 in the box. Never mind. Okay, we just got a ton of stuff. Let's go back up to the top band. We just got a bunch of digits. Let's see how that affects these other boxes. So I'm going to start with the one with actually the more givens here. So we have 1s marked here. The thing I'm looking for right now is I'm looking down to see if 1s are also restricted to those 2 columns in either of these boxes. And unfortunately, it doesn't appear to be the case. Okay. So we did the 1s. Actually, let's just go through every digit. The 2s are taken care of. The 3s are done. The 4s do put a 4 on one of these two. We have this 4 as well. The 5, does the 5 do anything? No, the 6. 6 is still these three. The 7 was taken care of. The 8. Okay, 8's one of these two. And then the 9. Okay, this cell here avoided a bunch of corner marks. In fact, this row is just down to 3 digits, and then the 2 is here. So this is going to be great. 1, 2, 3, 4. We need 5. We have 6, 7, 8. We need 9. Okay, down to 5, 9. In general, this is 2, 5, 6, 9. This can't be 2 or 5, so this is 6, 9 only. Nice. And this can't be 9, so this is 2, 5, 6. It can't be 2 either. So 5, 6, 6, 9, 2, 5, 9. This whole row is 4, 5, 6, 8. They're all worth marking. We have the 4, the 6, and the 8 here. So I'm going to write out 4, 5, 6, 8 and clean it up. That's not 6, that's not 4, that's not 8, as I said. And this is down to 1, 6, 9, and that's not a 6. Okay. So we've taken care of the top band as best as we can. I don't think there's anything more to do there yet. How about this band then? 6s are done. We do have these 2 4s now. It's a 4 on one of these two. And we have 2 7s. That puts a 7 in one of these two. Is there anything else I can do here? 4, 7, 6. I'm not seeing a whole lot. Let's just move on to this band just to double check all this stuff here. So the 3 we took care of, the 7 we took care of, the 8 took care of, the 6 we took care of. Okay. So what am I missing now? I'm noticing, so this column is down to 5 digits, and this cell's not the 3 or the 8 based on these corner marks. So I'm going to think about the whole column, but I think this bottom cell is going to be down to 3 digits or fewer. So what do we need? We need the 2, 3, 5, 8. 2, 3, 5, 8, 9. 2, 3, 5, 8, 9. So this is 2, not 3, 5, not 8, 9. This can't be 3 or 9, so this is 2, 5, 8. 2, 3, 5, 8. Oh, this can't be 5 or 8, so 2, 3, 9. Not really good enough, huh? These 2 cells aren't the 2 or the 3, so maybe let's, oh, this whole row is down to 4. Let's take a look. We need 1, 5, 8, 9. Oh, the 8 is limited. So these are both 1, 5, 9. I'm just not seeing other restrictions here. 1, 5, 8, 9. Huh. These don't really help immediately. Where else might I look? Huh. What am I missing? Maybe I should look at this row. We do have some corner marks poking into it, so we need 2, 3, 5, 7, 8. 2, 3, 5, 7, 8. This can't be 3 or 8, so 2, 3, 5, 7, 8. These both aren't 7. It can't be 2, 3, that can't be 8. Okay, so 2, 3, 5, 8. This can't be the 8 or the 3, and this can't be the 2. Come on, tell me 2, 5 does something. 3, 5, 8. Ah, geez. I'm finding a lot of restricted cells, but I'm not finding any like pairs or triples to help me out. I was going to say this column, but there's a lot left in this column. See, this can't be 1 or 1 or 9. Trying to cross-reference like the rows here to see if there's just a bunch of digits that aren't already placed in the column that are seen in the row or something. Because, I don't know, there must be some sneakily restricted cell somewhere that I wouldn't typically look. Maybe this row. I'm a little, you know, if I'm looking at rows, columns, boxes with 5 or digits left, that I'm desperate. Let's see, we have 2, 4, 5, 6, 8. 2, 4, 5, 6, 8. This can't be 2, 4, or 8. So 2, 4, 5, 6, 8. 5, 6, 5, 6, 8, 3, 5, 8, 5 times. It's like not quite there, huh? 2, 3, 5, 6, 8. This can't be 3 or 8. Oh no, sorry, not 3. It was 2, 4, 5, 6, 8. Not really seeing anything else other than this one. Hmm. 5, 6, 5. Gotta find something. We know none of these are 6. So this can't be 6. All right, 6 is placed in the box. I'd remembered these pointing 6s and these claiming 6s, but the 6 got placed, so that's easy. Where haven't I looked? I mean, this entire stack is done. You'd think that would get us something nice. Huh. I don't know where to look. Oh, we have a 1-9 pair here. I mean, the column's got a lot left, but maybe the 1-9 pair helps. Yeah, it's got 4 digits left. Those are going to be the 2, 4, 5, 8. This can't be 5, 8, so this is 2. Oh, this can't be 4, 5, or 8. This is a naked 2 because of the 1-9 pair. So we can place the 2 there because it can't be any other digit. That gives us the 5. Okay, very nice. And we also clean these up a bit. That makes a 3-9 pair here, so this can't be 9, giving us, this can't be 5, so this is 2, 8. Leaving the 5 for one of these two. That is going to claim the box. In fact, 5 in this box is in one of these two. So this can't be 5 or 6 now. Neither can this. Huh. So neither of these are 5, 6. So they can be 2. They can't be 3. They could be 4. They're not 5, 6. They could not be 7. They could be 8. Okay. Did I make any other? What is this? 2, 3, 7, 8? What about the rest of this box? We need 1, 3, 8, 9. This can't be 3. This is 1, 8, 9. This can't be 8. This is 1, 3, 9. So, oh, we have this 1-9 pair, though, that I didn't pay attention to again. So that's our 8. That's a 3. The 8 comes up placing this 8 as well. Okay, let's clean this up a little bit. 4, 5. 1, 9. So this is also 4, 5. We have a 1-9 pair. We have a 4, 5 pair in the column. We have 1, 5, 6, 9. This can't be 6. So the 6 in this column is only here. And this is 1, 5, 9. Okay. Does getting the 6 help me at all? 6 in this column's here. 1, 3, 4, 9. This is 1, 4, 9 now. Okay, I'm still missing something. That 1-9 pair was huge, though. 1, 5, 9 here. 1. 4. Okay, so something I'm seeing here is the digits accounted for so far are 1, 4, 6, 9, but there should be 5 digits. And so the what digit's missing? And the answer is the 2. So that means the 2's in one of these two, which is true of the box as well. Do I just need to pencil like, okay, this is a triple now. I got the rest of these digits. This is 2, 7, 8. Oops. Didn't mean to do that. This is 2, 7, 8. That's a 2, 7, 8 triple. So that'll remove 2, 7, and 8 from the rest of the box. Unfortunately, we already have 2, 7, 8 here and 2, 7, 8 here, so nothing really to remove. And this is 1, 5, 9. Come on, tell me we get something out of this. And this is 1, 3, 4, 9, which still can be any of them. This whole column has nothing placed. Why does it feel key? I mean, we got to place the 1, 4, 3, 7, 8 in it, along with whatever this 2, 5, 9 ends up being. I don't know if I can do anything with that. 1, 3, 4, 7, 8. don't think it helps me. Yeah, the only digit is that it's just these pointing sixes. That's it. There's nothing real special going on there. Let's see. Hung up on that for a second. Oh, I have a 3-9 pair here. Oh, we have the 3-9 applied already, and this is 2-5-8. Okay, so what am I missing here? I mean, what am I seeing here? Skyscraper? No. Well, technically yes, but it doesn't do anything. Just because I this isn't helpful in this puzzle, and it never will be. It never will be necessary in a puzzle like this one, like a New York Times newspaper puzzle. But I thought Skyscraper I haven't really explained in this series before, so might as well just talk about it while I'm stuck. So think about this column and where 9 goes. It's in one of these 2 green cells, and then I also have 2 cells here that are kind of want to be 9 maybe. So this is actually a W-wing. This is not, sorry, this is a W-wing. This is not a skyscraper, but it's interesting nonetheless. So we know that one of these 2 will be a 9. Whichever one becomes a 9 will make one of these 2 a 1. So what you're looking for is you're looking for a restriction in a row or column. It can also work for a box, but basically you've got a what's called a strong link, but you've got a 9 in you got a digit in 2 places, right? So in this case, the 9 is restricted to 2 cells, and they both see an identical bi-value cell. They both, in this case, they both see a 1-9. So what this is telling us is that either that at least one of these cells will be a 1. Now they could both be 1. There's nothing preventing them both from being 1, but they can't both be 9. If you think about it, if they were both 9, then we'd have nowhere to put 9 in this column. And so therefore, one of these 2 is a 1. Now, what is the consequence of that? Well, that means that anything that sees both of those cells cannot be a 1. And that's these cells here that I've made purple, right? These cells, no matter which one of these is 1, would not be able to be 1. If this is 1, it's because of the box. If this is 1, it's because of the column. Same with these 3 cells. And so this actually cannot be a 1. So we could use that if we wanted to. And it would actually place a 1 in this column. So that would probably finish this puzzle. For advanced techniques like this, I do like to point them out, just in case you want to learn. But I don't like using them because I don't want you thinking, oh, I had to know how to do a W-wing to solve the puzzle today. That's just not the case. There's going to be something simpler. But it is interesting to point out, and feel free to use it if you'd like to. I just don't use it in my walkthrough tutorials because I don't want people thinking they're necessary. But they are pretty fun. So just think about that. There's 2 worlds that exist. Either this is 9 or this is 9. In the world that this is 9, this becomes a 1, and this can't be 1. In the world that this is 9, this becomes a 1, and this can't be 1. So no matter what, this guy is not going to be a 1, and then now it makes that leaves only one place for 1 in this column. So pretty interesting thing there. And I'm going to highlight this cell here. Let's just make it green, just to remind ourselves that I proved this couldn't be 1, and then we'll see in the solution that it ends up not being 1, just as a little final proof there. But that said, I still need to figure out what's going on here. Okay, I'm seeing that this 1-9 looks in here, so this is going to be restricted. Let's look at the whole box though. We need 1, 2, 4, 5, 9. This can't be 1, could be 2, could be 4, can't be 5, can't be 9. So it's down to just 2, 4. So yeah, I said 1, 2, 4, 5, 9. 1, 2, 4, 5, 9. And it's not 1, 5, 9. And so that does make a 2, 4 pair in the row. That does place this as an 8, and this can't be a 2. That places it as a 5. That gives us the 2 here. That places the 2 and the 4 there. That's our 8. 2, 7 pair. Okay, and then this is a 1, 3, 9. Oh no, sorry, this has to be the 4 in the box. 2, 7 pair. What's going on here? Okay, 1, 9 pair. This places the 3. That gives us the 9 and the 1. And now that this has become a 1, we knew one of them would be. Notice this can't be 1 anymore. So there you go. So that's our 3. That 1 gives us the 1 here and the 6 and the 4, and that's a 9. Comes down, giving us this 5. That ends up 9, and now that's a 1. All right, and that's our 9. We get our 1. So actually both of them ended up 1, which I said was a possibility. Anyway, that ends up 9. We get our 6, 5, 2, 9, 5, 7, 2, 1, 5, 7. This is 1 and this is 4, and we're done. And this, sure enough, did not end up being a 1. It ended up being a 9. All right. Cool. Well, I'm glad I was able to show you that technique. It's not often that I spot something like that in a New York Times puzzle, because I'm mostly focused on doing the techniques that are in the list of required techniques to know to solve these puzzles, which is what I'm trying to reinforce as the kind of the basics of Sudoku. But yeah, it's always neat to be able to just kind of point out something like this. I don't think I've ever pointed out a W-wing before in any New York Times solve, so it's neat that I was able to do that today. And you can see that these definitely did not both end up 9. One of them was 1. In fact, both of them were 1. And that is always a possibility. And that's something you need to be careful of when you apply techniques like this. Apply the only the consequences that are logically deducible. You don't treat them as a 1-9 pair, right? We did not prove they were a 1-9 pair. We just proved at least one was 1. All right, cool. Well, I hope this was enjoyable for you. Let me know how you did on the puzzle. And if you did enjoy this, why not leave a like, subscribe, and a kind comment below.